that's what. So yeah, that's what like we try to solve here at Biconomy. So our first product was gasless, so which I'll be like going through it and showing you like what all we do here. Yeah. So as already mentioned in the last workshop, we here in Gasless do meta transactions. Basically, the person who is sending a transaction is not the person who is paying for the gas fees. So in a like a normal flow, that's how it is like when you maybe interact on a DeFi platform. Let's say Uniswap, you go over there, you connect your MetaMask. Let's say you want to swap a token. So there you pay the gas fee from your own wallet. And but in meta transactions, that's not the case. Like in that, like you just have to sign a message, and then the transaction gets executed by like a third party, maybe like in Biconomy's case, it's our relayers to execute this transaction. So the main reason for this is again to abstract away like this whole holding the native token and not like worrying about like if your transaction will get successful, like at what nonce it should send. Like let's say if the gas price is a bit low and you have to resubmit the transaction. So all those complexities that a general user would have to look into, dive into, and like wait for its transaction to get confirmed, the gasless product like kind of abstracts away from that. So it's something like when you go to Netflix or YouTube, you don't like pay for every video you watch or any action you do, like to maybe the hosted service, AWS. So it's basically that YouTube, which is paying to the AWS rather than you paying directly to the AWS to use its service. So just in that way, you can kind of abstract away all these complexities via meta transactions. Yeah, so how do meta transactions usually work? So for a normal user who is like interacting with a dApp that has Biconomy integrator or any like meta transaction framework, that user just has to sign a request. And there are various signature schemes out there. In the last workshop, EIP-2712 was covered, so personal sign was covered. So in that way, the user just has to like sign a message that's okay, so and so, this is what I like, let's say I want to do a transfer of tokens. So this is the transfer I want to do with some data, some nonce stuff that gets the signature validation later on. And then that basic signature, which is signed, basic transaction that's signed, that gets like sent to the relayer. And then that relayer like adds its own signature scheme to it. And then it calls like the final contract, which is basically the contract which has that execution logic in it. So the contract in the end like unwraps the transaction, and then whatever is said in that transaction, that gets executed on the contract side. So yeah, for this all to happen, as you can see there, there's a user which, like I mentioned, that signs the transaction params. Then in our case, we have a relayer infrastructure, which is basically our entire backend. And to interact with the Biconomy backend, like there are two approaches. Like you can either use the SDK approach, or like there's an API also that you can directly hit. So as mentioned here, this you have to send a signed transaction params via the HTTP. So this step is what we abstract away in the SDK. So it's just a normal SDK, which might be like any development toolkit available out there. So via this, like we interact and send whatever params we have to our backend. And then our relayer infrastructure basically does the nonce check, sets like what gas price to send it at, and like maybe just calculates the gas limit also, to like that has to be go in the transaction. Then that relayer just wraps the transaction and sends it to the final recipient, which can be like any arbitrary contract, but that contract has to be able to understand meta transactions. So there are some certain changes that have to be done on the destination contract for meta transactions to be able to interact with it. And that's where like EIP-2771 comes into picture. So as mentioned before, it's like a standard out there for removing the dependency of message.sender basically, because in this case, the final destination contract is being called by the relayer itself. It's not the user who's calling that. So let's say in a standard flow, if you don't remove the message.sender, it will be basically the relayer address that would hold its value. But that should not be the case, right? It should be the user whose address should go into the contract. So in that way, the 2771 implementation came into picture, and there were some standards that were written, like, okay, the destination contract has to have a trusted forwarder kind of thing, which it trusts that whatever calls that come from that trusted forwarder, those calls should only be processed in that contract itself. So this is a diagram that I picked up from the EIP-2771 standard only. So this showcases the entire flow that has to happen. And then this is the implementation that we have done on our end also. So we have a trusted forwarder in place, which are gas relay calls. I'll show the trusted forwarder code later on. And inside the trusted forwarder, all this signature verifications, nonce check, and the actual calling of the data happens for the corresponding recipient contract. So like, just to go over the flow again, like this is just the signer that we do from the SDK side in Biconomy. This gas relays the relay infrastructure that we have built in a backend. And so trusted forward is a deployed contract that exists on every chain, be it Mumbai, Ethereum, all testnets, etc., which is the same logic for every transaction. And then like whatever that recipient contract would be, then it would just go ahead and execute whatever it has to. Yeah. So yeah, just to mention over here, like we use this kind of feature of gasless transactions, and then we tell the user like, okay, like you have to do this, make your transaction, your contract basically meta transaction compliant, and so that their contract can start accepting the calls from the trusted forwarder that we have. Yeah, so I guess I have mentioned all this. So this is just signature verification, some replay attack protection, so that the same transaction is not broadcasted again. And we also append this user address so that the actual contract can also know which was the original user which called this transaction basically. I will show you one demo. First of all, I would like to go over some contract which I made 2771 compliant. So this is a basic, very basic solidity contract. So in this, there is a variable which is called quote. It's nothing but a string that holds an arbitrary value. And there's a function on it, which is basically set quote. And in this set quote, whatever new quote that is passed, that gets set on it. So the thing here is, like in a normal smart contract, you would obviously have like this message.sender thing, but because as I mentioned before, message.sender would be something that the relay in our case. So for that, we have to use this underscore message sender, which I basically get from the base relay recipient, which is an OpenGSN implementation. So both OpenZeppelin and OpenGSN have some standard contracts out there, which allow you to have this meta transaction capability in your smart contract itself. So this is one thing, message sender, that they expose. The second is the trusted forwarder variable. So as I mentioned, that you have to tell your contract, okay, like this is the trusted forwarder that I would trust, and this is something I would accept calls from. So in that flow, if the calls don't come from a trusted forwarder that the contract knows, so that won't follow, and the transaction would fail eventually. So yeah, as I was saying, so this set code is the blockchain transaction updation state that happens. And in this state, you just update that code, and I set the second variable, which is the owner, as a message sender. Also, there's one version recipient function that has to be overridden because it's a virtual function, but it's not something that would affect the flow. Yeah, so I have deployed this contract. Okay, but I can deploy it just a second. So yeah, I have first I'll walk you through the steps, like how to use Biconomy dashboard, like if you want to register in your app, and how to like integrate that in your code itself. So I have deployed this contract on Mumbai, and like I have the address and the API pulled up. So if you just head over to dashboard.biconomy.io, I can register that app over here. So it's a poly and testnet. So I would have a dApp with me. So I would next like kind of do some registrations in this UI so that our backend would know like what all smart contracts to look in this case, and basically what all methods one has to make gasless. So I'll just write them address and ABI so that all those contract instances and the function calls can be done. And also, like, I'll be choosing this trusted forwarder approach. We have two more approaches, custom approach and ERC20 forwarder approach. This I'll come back to in a short while. So first, I'll be adding this contract, then I'll be going over and adding the method basically, which I want to make gasless. So set code would be that method. And yeah, by this I can just have this kind of an identification in place so that a relay and backend knows that via the SDK, this is the function that would be used. And the last step would be to like using this API key and plugging it in my SDK code. So just to go over the code a bit, like you basically create an instance of the Biconomy class, and then you pass one JSON RPC provider and the API key that just to identify, okay, this tab has to do the transaction. So this is a public repo that we have posted also. In this, we have all the components that are required in like in a gasless transaction, be it custom with ethers, with various signature schemes, both with 712 and personal sign. So I use usually this to like test it out. And now that I have added all the necessary details, then I can just go ahead and do the transactions. And on the right, there are some logs related to the SDK that come up, which basically tell you that like what all current data is being fetched from the backend. So transaction. So here I am updating the code itself, and this will be the place where the code would be updated. And as I like showed you in that function, it's that this set code method would be called, and the owner would be message sender, which would be logged here. So this would be my EUA address. And but I'll show you like when the transaction happens, because the relay executes, the from address is not on the transaction, my own address. So yeah, it's each send transaction call that goes into the SDK, which is basically intercepts these calls, and it kind of adds more features to that. So because I was going via the 712 approach, you can see that there are some signatures that I have to do in place. So basically from is my user address, to is my destination contract, the transaction gas, and a deadline that comes into picture. So this data is basically what the final destination contract call has to implement. So once I do the signature, the SDK would return me with the transaction hash. Do you guys have any question till now? Yeah, do just post it in the chat box. Like I'll keep looking in between. Okay, till the time it gets confirmed, I can show you the Biconomy forwarder that we have. So this is our forwarder contract that every dApp like has to trust. It's an open source audited contract that like for this address, particular address that has to be set by the user who wants to use it. And there are various methods in it. So as mentioned in the PPT also, all these checks happen on our trusted forwarder. So some signature verifications, some nonce checks, and basically then finally appending that user address at the end that, okay, this business logic contract, which you have, can read like what's the actual user in this. So let's say I have an execute EIP-2712 process, like it's not personal sign, it's 712, then it's a simple, like basically that the very signature verification happens for it, and which is the EC recover for it, and basically on some type hash that we have defined in the contract, then some non-subdation, then checking that via this call method, and then if success, then okay, like the transaction is succeeded, and if not, the transaction gets reverted. Yeah, so like the transaction I did got confirmed, and the code got updated on as the test transaction. Now, if you see, like this address is not my address, it's the relayer's address that goes in. My address was 040. This address is the relayer address, because this is the one which paid the gas fee for it and called the blockchain to execute it. And other variants remain same. So what in our backend, what we do, we set the max fee, we set the max priority fee in whichever network we require. So this a relayer infra does it. And then let's say, for example, for some time, like let's say 50 blocks, the transaction does not get mined. So we bump it up and send it by a higher gas price. And eventually, like once the transaction gets confirmed, we resubmit the new hash that's out there. And yeah, as you can see, this is the relayer address. So on every network, we have a lot of relays deployed so that any transaction that comes in can get confirmed quickly. Now I can go over like the docs in general, like how everything works. But before that, there's one new feature that we have launched recently. It's called conditional gas list. So basically, let's say you want to incentivize some user who has been on your DApp like for a long time. Let's say it's some staking protocol, and a user has staked 1,000 Matic till now. And let's say a new user comes in and says like they have deposited 10 Matic. So you would ideally want the person who has been there and like contributed more to your staking algorithm to be incentivized more. So in that case, like we have this conditional gas list thing, where in various conditions, some gasless features can be implemented for some users, and for some, like they would be bypassed and be a normal transaction. So currently, like we have two conditions available with us. It's basically whitelisting which all NFTs that user is using. Maybe like that person might be holding an NFT or like by a certain amount, and some whitelisting of some tokens, basically like holding a minimum amount of those tokens would go in that. So this is the conditional gas list that we launched recently. Yeah. Yeah. So coming over to like gasless in general, this was like the 2771 approach that I walked you guys over, and it uses this trusted forward. It's a standard implementation that's out there. So we have a few more approaches. Like first is like the custom implementation. So sometimes like you need some customized meta transactions in your whole logic, and then for that, like you can't just have the trusted forwarder come in play, because the trusted forwarder has a standard way of doing things, but you want different signature schemes, or maybe like different maybe nonce check mechanisms and stuff like that. So then you can go ahead and like use the custom implementation. In that also, the main thing would always be to remove the message.sender. And we have two contracts. Like in 2001, there were audited contracts by OpenZeppelin and OpenGSN. Here we have two contracts that were made by Biconomy only. And then these are the ones like you have to inherit in a base contract. And then you can remove the dependency of this and do meta transactions in general. And the use case of this can be like TIE allows you to do meta transactions via its permit function. So for that, it does not take a trusted forwarder in its whole flow. It's usually their own signature verification that happens. And there are a lot of ERC20 tokens on Polygon that also allow this feature. Like they have this function called execute meta transaction, which has the capability of accepting meta transactions from any relay because they have that signature scheme, they have that nonce check and whatever things that are in the trusted forwarder. So this is the custom approach. It's the steps are still the same. Like you have to change this your smart contract to have this message or remove this message or sender dependency. And then we ask you to register some artifacts on the dashboard, and you can like then start integrating in your app and do whatever like transactions you want to do. Then there's a smart contract wallet approach also. So we have like, let's say a user has various smart contract wallets in Gnosis, Argent, which they have for the users, but they want to do gasless transactions on it. So currently the issue with relays out there is that you have to spin up your own relays with, let's say, OpenJSON or something. But with Biconomy, because you have that relay infra, you just have to integrate those contracts and basically do transactions on them. So we do support Gnosis, and there the user can just like kind of implement meta transactions in that. Yeah, the standard 2 cents approach I have already gone through. Yeah, so there are some steps like you have to have this set trusted forwarder method in that, so that the contract knows what has to be done. And yeah, the dashboard registrations like I showed, and yeah, some code changes. So basically this basically involves you setting up the SDK on your end, getting that API key, and we're like waiting for the Biconomy on ready event to go ahead so that you can start doing the transactions, because it takes some time for a backend to read the data that you want to provide. And in general, like so that the transactions, the provider that you are already setting goes via the Biconomy SDK provider. Yeah, there's also backend integration. So let's say usually on the front end, you have that window.ethereum or any wallet provider that can allow you to expose the signer and signature, this signer and provider classes of your provider. But let's say on the backend, you don't have that functionality. So what you can do is like have that private key on your end and integrate the SDK in the backend. And then you can like do the normal transaction like you would have done on the backend. So we have code examples for that to integrate like on the backend also. This is the repository that like I was using to do transactions. And in this, you can see the various components that are out there. So for every approach that we have for gasless, we have made various components like a front-end integration for them. So if you want to do custom, you can do custom with this signature scheme, and then you can implement this on your side. Yeah. So that's about it. Let me see if I'm missing anything. Cool. Any questions that anybody has? No questions. Okay. Cool. I guess that's about it. Thanks, guys. Thanks for joining.
Thanks, Yashasvi. Have you concluded the workshop? Okay.
Yes, yes.
Awesome. Just a quick note before folks leave, we have two sets of bounties that are coming up. One is on MetaPass, where you are encouraged to do events with the Phoenix Guild, and you can put up your tickets on MetaPass and win a bounty. And we'll be announcing a couple of other bounties on Biconomy, so watch out for both of those. Thank you so much, Yashasvi, for your time, and
Thank you, everyone.
thanks everyone for attending today. Sorry for this bit of like background noise, since we are at a hackathon, it's a bit loud out here. But hopefully you should also be able to revise the concepts using the recording once we release that out on the YouTube. Yeah, thanks everyone.
Thank you, everyone. Bye.